Hi everyone. So today we're cutting out the plexiglass. I wanted to show you how I go about doing that. So we have this part that we talked about in the previous videos. This is an assembly. One of the nice things you can do here is I can just go ahead and say I want to take this plate and I want to open it into a new window. So this is the plate that we will be cutting out. What I need to get in order to get this to the mill, to get this thing cutting, I need to create some toolpaths. So if you've never seen or heard about that before, well, first I would just say Google toolpaths and CNC toolpaths, right? What it's going to do is it's going to create a line for the cutter on the CNC to follow. So pretty easy concept right there. What I need to do though is take it out of my CAD program and get it to my CAM program. So computer aided design is the name for that. And then the CAM is computer-aided manufacturing. It basically means the computer helps us figure out how to tell the cutter where to go. Once upon a time, you would write G-code. There's another keyword for the day. You would write G-code by hand, and some people maybe edit stuff or possibly still write it by hand. But it's essentially a coordinate system. You just say go forward 2 inches, go left 2 more inches, go down a little bit, etc., etc., etc. Pretty simple, but you need to be able to do that. And so I'm not going to do that in CATIA here, and most of you will be doing this in something like Fusion 360 or possibly FreeCAD. If you're using FreeCAD, it doesn't have a CAM software connected to it. There has been some open sourcey stuff that you know, some groups that tried to do some stuff, but they dropped and they're not being followed up on. The only one that looks like maybe it might be promising is this one called HeeksCAD. So if you're into that, look that up. It looked like, well, first off, for me on my home Linux machine that it was on, I was not able to get it to work, and so it had some problems. It was interface problem. It was just like a weird open sourcey deal, you know, where you go in there and I don't see a button, I don't see a drop down, something's completely missing, something like that. So it sat there for a little bit, and then all of a sudden one day Linux, you know, pops up with some updates, and one of those updates was, hey, did you know there's an update for HeeksCAD? So I updated it, and sure enough, it works now. It's a little bit weird, it's a little bit hokey, but if you have nothing else or you don't want to spend money on something, take a look at that. All right, anyways, so we need to create a toolpath for this, but in order to do that, I can't do that with the 3D design file here. So for example, this part right here, when you save this as its master file, if you will, in the file type of, you know, your CAD software, it understands that this is a pad, and then based on a sketch, and there's a pocket. It was based on a sketch and possibly any other thing you did. We need to turn this into kind of like a monolithic pile of stuff, right? Something that we could just export out of here and say, this is just a lump, and could you please deal with this? And so the way we do that is you can export it. Now, all these softwares, a lot of these softwares, they don't always call it export. Sometimes they say export. In the CAM software, they'll say post, because that's been the word forever. And other things, we just do a save as. So here, in this case, in this program here, we go save as, and it says, where do you want to save this? And I want to save this onto my memory stick here, and I'm going to put it in. This is a habit of mine. I make a little STL file in there, so it keeps all of this type of file separate from the rest. So there's our clue right there. We're going to export this as an STL file. That's a stereolithograph. Some people use STEP, other times we'll use IGES for different things. I'm just going to go STL. And you can see that I already have one right here. I'll go ahead and just hit that and overwrite it. No big deal, just for the sake of showing you how this works. Obviously, I've already done this. Matter of fact, we've already, you know, went out there and cut one of these already. Whatever. All right, so that's done. Nothing changes here, but we've exported it as an STL file. Now, another little bit about that. The STL file makes the thing look like, well, it doesn't look like, it's a bunch of triangles. So if I were to change the view style here, I can actually do this and show you kind of what it'll look like. This is showing you all the triangles that are in this part. So think of it this way. Why triangles, right? Well, anybody that plays games, you know, especially in the older days, we were talking about, oh my gosh, you know, look at all the triangles, or look at all the polygons, right? How many polygons are in that guy's face? Oh, there's only 4. Wow, you know. Well, let's start with 1 point. 1 point, you can't anchor anything to. You can anchor it in space, but it's going to wobble all around it. If you have 2 points, you could anchor a flat thing to it, but it will wobble side to side, if you gather what I'm saying. If you have 3 points, if you take your hand and you put 3 fingers out in your other hand here, and you stick one finger to it and the other and then the other, your hand is now locked to those points. It will not move. So this is the reason for triangles. The 3 points described in a triangle are the minimum what's necessary to create a plane or a flat surface. So in anything 3D design or 3D, that when you export it out, we need it to be a bunch of flat 3D surfaces. Now, if we put billions and billions of these into something, they'll be so tiny that you won't recognize it. You won't see them, and then the game thing, face, monster, bot will look pretty smooth and slick. If you don't have so many triangles and they become large triangles, then it looks like, you know, Half-Life Quake 1, right? So that's the reason for triangles. If we have, for example, in this piece right here, there is a square, let's say right in this spot. One square, 4 points, actually gets turned into 2 different triangles here. So if you follow this here, point here, point here, point here, one triangle there, one triangle there. So flat surfaces aren't going to generate a lot of triangles, but then even when you look at the side here, you see, look at this. There's a lot of triangles going on here, and this is solely because of this hole. You cannot make a perfectly round circle. It's kind of in the design of this. You draw it as a circle, but it creates it as what we usually call a polyline. It's you don't make it as a polyline. You say make a circle, but it saves it as a bunch of straight lines. So imagine you got a straight line here, a straight line here, a straight line here, a straight line here. And that's going to describe this circle. Then the same on the bottom. Now, in order to create flat faces on this, we again need to make triangles. So we connect this point to one down here to over here. Then from this one here and this one here, another triangle, and so on and so on and so on. Now, back over to here, these were all nice, pretty flat faces. But because we put this hole in here, and because of the polyline going around here, and because of the triangles right here, the points that were created right here have got to be connected to something on the top. So now it jacks things up and it puts a bunch of triangles on our flat surface. So 2 points right here are going way the hell over here to connect to one point, back over to here, another one, another one, another one. So again, triangles everywhere. So that might be a little bit more than you need to know right now, but that's what's happening. So we're going to export an STL file, and an STL file is comprised of a bunch of triangles. So, how many triangles does this thing have? Well, in CATIA, I found out years ago, I thought it was really interesting, it gets it from your graphic settings. So if you have this thing, and you go into your if you're just running CATIA, you go into your graphic setting, and you say, hey, I don't really care how pretty it looks. I want it to run faster, so I'll just knock down the pretty a little bit. Well, when you knock that down, it lowers the resolution of the STL file. It creates the STL file from your screen resolution. That was very weird when we first started printing, 3D printing, because I made a thing and I made this assumption that it was just going to figure it out and it's going to extrapolate, and say that, hey, this is a circle, so make it a circle. And I made this coupler, connector, something or another, and it was incredibly faceted because I had a low polygon count on for the display properties. Crank that sucker way up. Even if it crashes your computer, which probably won't happen nowadays, but even if it crashes it, just crank it up temporarily just so you can export the STL file. All in all, that's kind of dumb, but that's the way it's done. If you're in Solidworks, when you export the STL file, it'll ask you how many triangles do you want, and it'll even tell you, it'll pop up and say this STL file will be built up of so many millions of triangles. Is that okay, right? Similarly with the other graphics programs, the CAD programs. All right, enough of that. So we've exported it as an STL file. Now we'll go over to the 3D or the CAM software, and we'll import the STL file in, and then we can look at generating toolpaths. I use Mecsoft up here. If you look here, Mecsoft VisualCAD. Okay, let me explain the CAD part of this. Once upon a day, somebody in the world, they create a CAD software. Then somebody else creates a CAM software, and that's that, and all the definitions are pretty nice and clear, cut and dried. Well, the CAD software possibly start making CAM software and integrate it into their CAD software, so then they become CAD-CAM softwares, right? So there's that word. And then the CAM people start putting a little bit of CAD stuff in their stuff, so the CAM software of the past might actually do some rudimentary CAD software. God, I hope I said it all right. So anyways, this is Visual Mill, and I use it as CAM software. Mecsoft has VisualCAD, which is the all-encompassing piece of software here that will do, well, I think we can look right up here. It can do Free Mill. That's the free one that they offer that's kind of free. Visual Mill, so this is good for 2 and 3 and 4 axes milling. Visual Turn, and some of the others here, well, Visual Turn is for running a mill. I actually don't know what Nest is for. I just haven't ever looked for that. Visual Art is a thing that I bought a license for once upon a time, and that is very cool. It allows you to, it's not for any other type of machine. It's for milling as well, but it allows you to bring in a grayscale photograph. So you find a photograph, picture of your face, right? And you convert it to grayscale, you bring it in, and then what you can do is you can say something like, anything that you see as white, make that be 0. Anything that you see that is black, let's make that a 1/4 inch, because maybe your stock is a 1/4 inch or just, slightly more or less. Then what it will do is it will figure out all the different values for gray in kind of a mapping to create, layers of height to colors of gray. So then what you can do is you can mill out a 3-dimensional profile to some degree of your face, because wouldn't that be cool? Alright, so that's the different things that this CAM software can do. What I am going to do here is just take the simple shape that we made, and we're drilling holes and we're cutting out a profile around the side. Nothing real major spectacular. So to kind of make this a little bit brief, I didn't want to turn it into a major tutorial, which I will do, and other things if you care about this software. This one, by the way, the cheapest copy you can get outside of the free mill that you saw up there, I want to say it's a little bit over $500. That's a lot of money, but it is kind of okay. I don't know if I want to say okay. It's fairly normal, even a little bit on the cheap side. If you want to have other pieces to it, because of course, like everything else, you get, you want more, you want a little bit more, then they're going to charge you more and more for it, right? I think the regular copy starts getting closer to $1,500, maybe more than that. Anyways, Mecsoft VisualCAM, if you want to check that out. Alright, so I already have a couple operations in here, and this is under 2 axes operations. So a 2 axes, or sometimes they call it 2.5 axes operation, will allow you to create a just say like an XY, a flat shape. Just say like you're going to draw on the table, right? 2 axes. Except the half axes is the fact that it can step down a little bit. So for example, these holes right here, these are a 2 axes profiling. It's going to go around, it's going to make a circle like this, but then it's going to drop down a little bit and make the circle again, drop down and make the circle again, drop down and make a circle again. It's going to do what you told it to. As opposed to in other operations, some of the 3D stuff here, it takes the model into consideration. And what I mean by that is, if I were to lay this out here and say, mill away from this block that's 3 inches thick everything that is not my part, it will keep milling down and milling down and milling down until it gets to the part and stops, and then goes around the side here and profiles it all out. Okay, taking the part into consideration. The 2.5 axes operations here, if I open this up, all of these things that you see right here, these different regions, each one of these is the circle that outlines one of these holes. It is not the hole. It doesn't understand that. It just says, hey, I see that you've selected a circle. Matter of fact, it doesn't even care that the part's here at all. I could delete the part and just make a circle. And what you're doing is you're saying, go around this circle. I would like you to go around it and keep going round and round and round until you've went 0.27. The plexiglass I have is 0.25, so I go a little bit further. And I'd like you to go down 20 thou at a time. So it goes around, drops down 20 thou, goes around, drops down 20 thou, goes around, drops down 20 thou, until it gets down to 0.27. Again, like I said, it does not care that the model is actually here. We're using the model, though, to get this circle so that we could put it here in our, into our machining features. Okay. When you're done picking everything you want, These CAM softwares, they have other things, like if you're picking a gajillion little holes here, you can do sorting, and you can say minimal sort distance, so it doesn't do this one over here and then the one over here in the corner and then the one over here, and however order you picked them in. By the way, it does, without this, do them in the order that you picked them in. Then you hit generate, and when you generate, it creates the toolpaths for you, and if I look really close here, there's our toolpath right here. It's saying take the tool and run around here, run around here. This is the center of the tool that you're using to cut with. We're using an 1/8 of an inch cutter, so it's really not moving much. It's just sort of orbiting around just a tiny little bit. This line here, again, it's the center of the cutter, so it's an 1/8 of an inch end mill, 0.125, so that means 0.0625 is on one side and 0.0625, on the other, if you will. Alright, so that'll get the holes done. Then to do the profiling, I do another 2.5 axes profiling, but I just use one region, and this one region is the outline of the whole thing. And here, let me get over here so you can see a little bit better. Whoa, kind of gets jerky. There's all our little step downs. Goes around, down, around, down, around, down, around, down, until it all cuts itself out. Now, when we get out to the shop, I will talk about, or you'll see that as we're cutting through the plastic, I did not choose to leave any tabs. Tabs are a thing that you can do. You can leave a tab behind so that it anchors this part to the outside thing that it's cutting from, so it doesn't fall away. We will be using a vacuum table to hold it all down, so I felt, I wasn't certain, but I felt that I could get away without using tabs, and hopefully the vacuum will hold the thing down in the middle and it won't release and start wobbling around as I'm trying to cut it. When it cuts through the final layer and gets into the vacuum table, you will see in a minute. Later in that video, you will see me also doing some stuff with some masking tape. As it gets down to the last little layer there, I'm going to start pecking around with it, trying to feel how much vacuum is getting lost as it cuts through the final layers there, and you'll see me tape some of the sections down, trying to keep and hold the vacuum, because I'm not sure, again, if it's going to hold the center section in place and if it will release and start wobbling around. At the end of it, when it's all done, I lift the cutter off and back it all away. I take the tape back off with the thing in place still, and I try to move it around, and I am happy to say that in this particular case, it doesn't wobble around. So for part 2, I don't think I'll do that. I do have 3 pieces of plexiglass, so if I screw one up, I don't want to, but if I screw one up, it won't be the end of the world. I can do it again. So watch that, think about that later when we get into the video, the actual cutting, and you'll see what I'm talking about. So hit generate with that, and there's our two tool paths. So this one here, holes, second operation right here, tool paths. This is pretty much the same all across the board for CAM software. If you look at Fusion 360, by the way, highly recommend going to HeeksCNC. They have a lot of videos there on Fusion 360 and just general amazing videos on cutting various things. So when you're done with the toolpaths, the next thing to do is export all of the toolpaths as G-code, which again is just point information saying where the cutter should go in the toolpath. And right here, you right click on the entire setup. So this is, I'm not going to pick each one of these. I could pick each one individually, but if I pick the top folder, if you think of it that way, I'll get both of them. So you post this, and it says where do you want to save this at, and I'll just save it as this name. I've already done it before once. And this is going to be your G-code. The thing that you have to know here, though, is which CNC do you have. For pretty much all the DIY CNCs, EMC inch is the one you probably want. If you have other store-bought mills, Sureline, Flash Cut, Grizzly, etc., those ones, you'll pick that from the list here. If you pick the wrong one, you very likely might get strange results. So just letting you know. So you hit post, and I'll just say replace this one, and then what pops up is this right here. So this is your G-code, old stuff, and this is probably what, since the 60s here. These are all the N numbers here. These are all just line numbers, and then your G numbers here are saying things like go here to this position. So G0, G02, this is actually going to make an arc. G01, move to a different position. G00, there's probably one in here somewhere. We'll just say go to that spot as fast as you can. Usually that's like when the thing comes up and it just needs to go over to make another hole. Okay, so we don't really nowadays have to modify too much here. Possibly, depends upon your setup. What I like to do is mess around with the stuff here in parentheses, because you can leave yourself notes. In this particular post here, in this particular G code, parentheses is it. Sometimes it might be slashes or it might be hashtags. So I could just type in here and say, hey, dummy, you know, don't forget to do something, right? Give yourself a whole checklist of things to do before you turn the mill on. Okay, close that. We'll save that. And now we take it out to the mill software. The G-code software will be read by the software for the control board on the CNC and tell the control board how to do the steps. The control board will send those steps out to the motor drivers, and then hopefully you've already calibrated this thing, and then the thing cuts. Lastly here, I forgot to show you simulate. That's kind of cool. You can go to each one again individually, or just right click on this and say simulate, and it will simulate the cutting. So that's kind of nice. And that's pretty much what you'll see out there. The thing that's more than just nice about this is you'll have a compare button, and you can hit this, and what it'll do is it'll show you through colors here how far off you are. So anything green is less than 0.6 of a thou accurate. This part here is going to be fine. But if you ever were cutting something that had a lot more three-dimensional nature to it, as you start cutting down, shaving it into part, that's pretty darn handy. Alright, let's go mill stuff. So cool, we got one done. We got one more to go, so we'll finish that one up here. And then I have the other pieces to 3D print, the side pieces here. So I'll close this here. Yeah, sure, why not save it? So these would probably be next on the hit list. These guys right here. Start screwing this all together. This is going to take a little bit of time, so I got to mill these out. I don't know. Maybe I'll show that in the video with the 3D printing. That's not very spectacular looking. Anyways, we'll get these parts made here. We'll assemble the thing, and then I guess we can test. So thanks everyone for watching. Remember, subscribe down below if you like watching this kind of stuff. I have no intention of stopping the channel. I'll keep making more and more and more. We're up to, I don't know, about 28, 30 videos now. I'll just keep making more. We do a lot of stuff here, so hopefully that's of interest. Have a good day.